Hello, my name is Tobias Rebholz from the University of Tübingen, and this is a pre-recorded talk for the 2023 virtual meeting of the Society for Mathematical Psychology. This project on Bayesian advice taking was done in collaboration with Hütter from the University of Tübingen and Andreas Voss from Heidelberg University. We investigated participants' adaptive strategy selection in sequential advice seeking scenarios, the preprint of which is available at PsyArchive. In sampling extensions of the traditional judge-advisor system, participants typically have the opportunity to freely and sequentially sample multiple pieces of advice per trial. Consider the hypothetical example on top of the slide where a participant's initial judgment was slightly smaller than a first piece of advice received. Then he received a second piece of advice that was slightly below his initial judgment and a third one again in the range of the first piece of advice, such that this participant shifted his initial judgment in the direction of the two pieces of advice that were higher than his initial judgment. Informational influences in those sampling extensions are typically measured by the so-called ratio of differences weight of advice, where the distance of the final from the initial judgment is set in relation of the distance of the sample mean from a participant's initial judgment, such that a value of 0 corresponds to neglecting the advice, whereas a value of 1 corresponds to complete adoption of the sample mean of advice. Most importantly, by assuming the simple averaging of multiple pieces of advice in this ratio of differences formula, this implies that the corresponding weight of advice index measures the total influence of all equally weighted pieces of advice that the participants may have sampled. In the first sampling extension of the original paradigm of Hütter and Ache, participants had the opportunity to sample as many pieces of additional advice as they like, at least up to a threshold of 20 pieces of advice. The most important findings of which were that more distant advice is sampled significantly more frequently than closer advice, that larger samples and more distant advice are weighted significantly more strongly in total due to the way in which the ratio of differences weights are calculated, than smaller samples and closer advice, and that final confidence is significantly smaller after having sampled more distant advice, but only in experiment 3 also for larger samples of advice. That is, in summary, the sequential nature of the sampling process is not explicitly taken into consideration, whereas there is empirical evidence, for instance, that there are serial weighting patterns such as primacy or recency effects in participants' belief updating. Instead, we explicitly take the sequential sampling process into account by implementing participants' beliefs about the true value of an item as being centered around their initial judgment E0 with initial subjective confidence C0, and where uncertainty about the true value motivates the sampling of external information such as advice, which is assumed to be normally distributed around the true value of an item, that is, implementing the appreciation of the wisdom of crowds, and with inverse variance tau inverse squared, where first stage intuition of participants' beliefs about the precision of advice are implemented as another updating process with internal sample size L0 and similar expectations about Brunswickian and Thurstonian uncertainty. By applying Bayes' rule, we find the following set of equations for participants' step-by-step Bayesian belief updating, the most important part of which is participants' sequential judgment updating in the last equation, which is implemented as a sum-to-one constraint weighted linear combination of previous sampling steps, posterior judgment, and the new piece of evidence AK, the corresponding Bayesian weight of advice, which in line with information integration theory implements external versus internal inconsistency discounting such that a certain piece of advice is weighted according to its relative uncertainty in a certain sampling step. On this slide, we can see an artificial example of step-by-step Bayesian updating for 3 sampling steps, where the prior belief distribution, as plotted in red, is updated to the blue posterior belief distribution in response to sampling the advice as indicated in black, Also note that in the third sampling step, the updating in response to the most distant piece of advice is much smaller as compared to the previous sampling steps due to the updating of participants' confidence. That is, the step-by-step Bayesian weight of advice is a function of the current level of confidence and the distance of a certain piece of advice, such that Bayesian updating dynamically represents all three judgment strategies found in traditional jazz research. For instance, in the top left panel of this matrix, the weight of advice converges to 1 for close advice and low confidence participants, whereas it converges to 0, that is choosing the self, for more distant advice and high confidence participants, and is populated around the equal weighting threshold of 0.5 in the other two cells of this judgment updating matrix. In contrast to sequential updating, if we assume a joint prior belief of participants about the true value of an item and the variability of advice being normally inverse chi-square distributed, then Bayes' rule leads to an updating equation from an end-of-sequence perspective, according to which the final posterior judgment is again a sum-to-1 constraint weighted linear combination of the sample mean of advice and a participant's initial judgment, where the corresponding Bayesian weight of advice implements egocentrically biased simple cumulative averaging by weighting the advice according to the relative sample size of the sample of advice and participants' own initial beliefs. If we compare those two Bayesian compromising strategies to the conventional choosing strategies for the data of experiment 5 of Ache 2017, then on the one hand we find that step-by-step and end-of-sequence compromising is a much and significantly better prediction of participants' final judgment, whereas the choosing self strategy, that is sticking to one's own initial confidence, is a slightly but not significantly better prediction of participants' final confidence as operationalized by the final standard deviation of their belief distributions. If we look at the same plot separately for the close versus intermediate advice distance condition of Ache, then we replicate a traditional single advice taking finding, namely that choosing the self is a much better strategy in response to close as compared to more distant advice, whereas for the final standard deviation, the only notable difference is the ranking reversal for the two compromising strategies. Nevertheless, in general and for all but the end-of-sequence compromising strategies, we only find a rather weak relation for the predictability of participants' final standard deviation and their final judgment. For this reason, we also conducted holistic belief distribution testing by calculating the Kalb-Leibler divergence between participants' actual and predicted final belief distributions, for which we basically replicate the findings as for the individual parameters, namely that step-by-step and end-of-sequence compromising perform best, in this case on median, whereas the largest performance variability is found for the choosing self strategy. We also calculated the relative shares of best strategy fit per participant as measured by the Kalb-Leibler divergence, for which on the one hand we find that for a bit less than 1/3 of cases, the choosing self or one of the two compromising strategies is the best description of most participants' behavior. However, there are also large inter- and intra-individual differences as indicated by the thin gray lines in this plot. For instance, the participant in the top left part of the choosing self strategy is perfectly described as a self-chooser across all 20 trials of experiment 5 of Ache, whereas most other participants apply different updating strategies for different trials of the experiment. Again, the same plot separately for the close versus intermediate advice distance conditions, where the most notable finding is the replication of choosing the self being the best description of most participants' behavior in the close advice distance conditions. To wrap it all up, in terms of participants' adaptive strategy selections, we find that on average, actually, most participants' final beliefs, that is around 60%, are relatively normative in terms of best strategy fit of one of the Bayesian type compromising strategies. However, despite participants realize relatively large samples of advice, egocentrism is actually as pronounced as in single advice taking situations with around 28%, and moreover we find large inter- and intra-individual differences in participant strategy selections. That is, in summary, participants apply a mix of strategies also in sequential advice taking situations that are comparable to single advice taking scenarios, for instance the adaptive reactions in response to receiving distant versus closer advice. For a comparison of the two Bayesian type compromising strategies, it is important to note that the total sample is generally more representative, such that it allows a better assessment of the Brunswickian, that is, external uncertainty. However, for large samples of advice, specifically for samples of advice that are larger than 4, cumulative averaging requires central capacities that most individuals in general cannot mobilize. Moreover, the weighting according to the proportional diagnosticity of Thurstonian versus Brunswickian sources of information is in line with information integration theory. That is, there is empirical evidence, for instance, that the uncertainty changes with the exploration of the environment, which is taken into consideration for the step-by-step Bayesian compromising approach. However, there is also empirical evidence, for instance, for overconfidence or against strictly growing confidence, which somehow restricts the applicability of a normative account that implements judgment updating exclusively based on relative uncertainty. An important finding in terms of future research is that more memory demanding strategies, that is end of sequence compromising and choosing all others judgments, actually realize significantly larger advice samples than less memory demanding strategies such as choosing the self or step-by-step compromising. And as closer advice was found to be sampled less frequently and in single advice taking research being typically found to induce confidence boosts rather than judgment shifts, the idea would be to, in order to implement informative stopping criteria in future research, to employ posterior confidence thresholds to predict participant sampling decisions. That's it from my side. Thanks a lot for your attention, and I'm looking forward to our live discussion. And here you can also see the references for this presentation.